A Linux hardened repository is an excellent choice. It's a robust, powerful first line of defense, and it leverages that XFS immutability flag to protect your backups. But what happens if an attacker gets their hands on the one thing that can bypass that flag? This brings us to a really interesting technical challenge: a single point of failure. It's an architectural vulnerability that every single data protection expert really needs to have on their radar. In so many backup architectures, one single compromised credential can become the very definition of a SPOF, bringing the entire security chain tumbling down. So, how do we engineer our way out of this paradox? We've got to think like architects and build a much more resilient solution. And that means moving to what we call a double-layer immutability approach. It's made possible by a very specific and very powerful technology, the ZFS file system. ZFS uses a technology called copy-on-write snapshots. Now, these are atomic, read-only, point-in-time views of your data. And here's the crucial difference. They're not just copies. They are pointers to the actual data blocks, frozen solid in time. When you build on a stronger foundation like OpenE JovianVHR with ZFS at its core, you unlock these amazing synergistic payoffs across the board in performance, data integrity, and even your total cost of ownership. This all starts with guaranteed data integrity. ZFS uses these heavy-duty 256-bit checksums to constantly verify your data, and it actually self-heals any silent corruption, what we call bit rot, before it can ever become a problem. You also get incredible enterprise-grade performance through advanced caching and compression to speed up your jobs. And because OpenE JovianVHR is hardware agnostic, you can deploy it on the commodity hardware you want, avoiding vendor lock-in and seriously optimizing your TCO with a predictable subscription model. So the question is, why would you settle for a single lock when your expertise allows you to build a vault?